you're doing good. I was talking to somebody and he said that separate microservices should have separate databases like this. Here you have two services, A and B, and each of them has a separate database. B should not be able to read A's database. It should make a network call, an RPC to A, which reads its own database. So a database is exclusive to a service in this point of view. The other point of view was that you should have only one database. Which of these points of view is correct? The answer is, or at least my opinion is, at a certain scale, you need to separate out the databases because each service offers a contract which it needs to adhere, and it needs to have control of its underlying layers to adhere to that contract. And the constraints that you have are typically enforced partly at the database layer and partly at the service layer. Let me give you an example. At Google, you have a contacts service. So if you try to go to contacts.google.com, this is the one that goes to the contacts backend. You see a list of contacts. Gmail needs contacts. When you're typing an email, you type an email ID, it auto-completes based on your contacts. But it does not have direct access to the contacts database well, it doesn't have direct access to the contacts database. It has to make a call. At scale, this is the only solution that works. The shared database thing would break down. So let's take an example of a constraint and see how that would be enforced. So assume that A here is a contacts database, contact service, and this database is a contacts database. Let's assume that we support only internationalized numbers, like with a plus sign in front. So if I type a number without it, let's say some number, this is a number in India. Let's say the contact service, which is A here, would prepend +91 or whatever the user's country is to the number. So when you make a call to A to read the contacts, it will always return to you in this format, even if while writing you did not give the +91. So let's say that's the contract of this service A. Now that can be maintained only if it controls its own database. If B can write directly to A's database, B can insert a number like this into the database. And then when someone invokes A using the RPC interface and says get this contact, the contact will not be properly internationalized. Then A has violated its contract because somebody else has messed with its database. So you can see how at a certain scale, like at Google scale, this option of separate databases is the only solution. But you are not Google. So start with one database to reduce work, right? Assuming you are going with microservices in the first place, we are not talking about monolith versus microservices in this video. Let's assume you have multiple services, A and B. Start with a common database. That will reduce the work a lot. Think about provisioning the database. You have to check whether the CPU is sufficient. If not, increase it. Check whether the memory is sufficient, increase it. You may need to update MySQL, let's say. If you have two databases, you have to do it twice. Engineers may need to have access to the database for troubleshooting. Again, that has to be done twice. Let's say you have failover, you have a master and a slave and it fails over. You have to check that your code works correctly when the failover happens, the service layer code, the backend code. Even if the database handles it correctly, the service also has to handle it correctly. For example, if it stores the IP address of the database, that won't work because the IP address will change when it fails over. So Java servers sometimes have problems with this because they cache the IP address. So this is a problem that needs to be handled or checked twice. And databases have option groups and parameter groups, which need to be configured. And if you're running multiple databases, the configuration can be different. One of the problems I dealt with in MySQL is a replication lag, where you have a replica, but the replication lag was like hours. In this situation, you deal with the problem once. In this situation, you deal with the problem twice. You have to set up alerts for production. So the database is out of space or any number of things, right? Latency is too high, it will page you. You have to do that once here and twice here. So more the databases, more the services, more the programming languages, more leads to more complexity, which is why, as my friend Aditya Dalmia recommends, and this point came from him, he strongly recommends this architecture for that reason. And I would say you should start with this architecture until you scale to a very high extent. Someday, if you're operating with hundreds of millions of users and lots of services and so on, great. Then you do this. You split databases. Until then, don't overcomplicate your life. Use a shared database. And you can have rules saying that, for example, some tables belong to service A and service B cannot access them. Or it can access them, but it can only read, it can't write. These kind of rules you can enforce in an informal way in your team rather than having to split databases. So use this as long as it works.